Welcome back to HANA Basics for Developers. In the previous video, we looked at the specific modules and techniques for performing HANA database queries from pure Node.js modules. We want to continue that topic, but now look at the specific way that we can interact with stored procedures. Of course, the syntax for accessing a stored procedure with the call procedure SQL syntax is a bit different than just performing a SQL query, but the impact that it has on the way that we use it from, well, really any environment, whether it's JDBC, ODBC, or via the HANA client in Node.js, is a little bit different. And we saw that earlier when we looked at XSJS. There was different database APIs for calling a stored procedure than performing all the other SQL query types. And we largely want to pick up right where we left off, where we were extending our EX2 router. And in here we had our various different database queries. We were just performing the same query over and over again, but using different techniques. We learned about third-party modules to help us, promises, and async await. So let's add another handler here, but this time we're gonna work with some stored procedures. So as we said, the logic is gonna look a little bit different here. Let's go get our code snippet. This is 5db6.js. And once I grab it here, we'll look at the code in a bit more detail. There we are. So we want to call stored procedures. Same thing here, we get the database connection from the request object. We're going to use the HDB-EXT module. The wrapper module is particularly important in this case because it's got a special function for directly working with stored procedures. It's got this loadProcedure function. And what we have to pass into it is we have to pass an instance of the database client. So that's that's passed in from Express. That's already initialized for us. If we are not working with a container, then we have to pass in the schema. Now we are in a container connection, so we just want to pass in null here. So we still have to supply a parameter, but we want it to be a null value. Then we have to give it the name of the procedure that we want to call. So that's what I've got right here, get PO header data. That's one of our stored procedures that already exist over in our database module from earlier exercises. So get PO header data right there. That's the procedure that we're going to call. It's got no input parameters, and it's got one output parameter of a table with full name, create count, change count, and combined count. Okay. Then you have to pass in the callback function. So here we're going to go back to we're going to start simply, and we're going to use our approach that we started with just embedded callbacks. So obviously if there's an error, we'll get the error object back. Otherwise, we'll get like a proxy object for the stored procedure. And that's what this SP is. If there's an error, of course, we want, just like we did earlier with all of our database queries, we'll send that error back in the response object and set the status to 500, so server-side error. If not, then we want to call the stored procedure. And what we have coming in here is we have a JSON array of the input parameters. In this case, there are no input parameters, so we just pass in an empty. We have the empty brackets here to denote that there are no input parameters. But even if you don't have input parameters, you have to send in that empty bracket. Then we have a callback here, and in this callback, we're going to receive first any errors, second any output scalar parameters, and third, any output table parameters. And in both these cases, you're not getting multiple you're not going to get multiple output parameters. All of your scalar parameters. Let's see, if we had 10 scalar parameters, you would still just have this one parameters object, and it's gonna pack them all. It's just going to use JSON to pack all the actual SQL script output parameters into this one variable. And the same thing with output table parameters. We're not there actually we are going to get. Unlike the scalar parameters, we are going to get multiple outputs. So it is we're going to get an array of outputs. In this case, we knew that our source only had one output table parameter, so we didn't really need to account for that. We could just list the one results object. And if you're calling a table function, if you're working with a stored procedure that only has one output parameter, that's certainly the case, is that we're going to only have the one there. So next we see, we have to handle the errors, of course. If it was successful, though, results will be filled with the data. In this case, we're able to just stringify that so that we can put it back into the output and set the status to 200, which is good. And then we have called our stored procedure. We're good to go. So why don't we go ahead and rerun the module. There we are, it's restarted, and now we can test it via the web module. We'll come here to Node EX2 procedures. And there we see it. Our output parameter, EX top 3 employee PO combined count, right here. So the name of the table, that's exactly the name of the output table, and then it's taken 3 records that are returned and formatted them as JSON. We don't. It's one of the nice things about working with the HDB-EXT and the node wrappers. We pass in JSON into our parameters. We get JSON back. We don't have to worry about converting to HANA database types or dealing with record sets and converting that to JSON, and some of the things we had to do in the XSJS APIs. This speaks JSON natively, so it's very convenient and pretty easy to use here as well. So now that was a simple stored procedure, no input parameters. Why don't we do a second example here where we do have some input parameters? So let me go ahead and grab that code snippet. And we'll bring that in. Here we are. Now, first of all, it's going to be interesting because this is really the first RESTful service that we've written that has some input parameters. And what we're going to do is we're just going to expect that the input parameter value is going to be supplied on the URL, that it's going to come at the end of the URL. And that's what we're doing here by putting a colon and then a variable name with a question mark. We're saying to express to take whatever comes after procedures 2 in the URL, take that as an input parameter, map it into a variable with the same name, and by putting a question mark on it, we are saying that it is not required. Okay, and then Express will do the validation for us. For instance, if we had said that it was required, then Express would automatically respond back if it didn't see anything in the rest of that URL. And we're able to get that parameter. Express pulls it out of the URL for us. We don't have to parse the URL. It puts it into the request object, and just like it did the database connection for us, and it's in a sub-object called parameters, and we can have multiple parameters, of course, coming in the input, but it's going to give it a named variable inside this parameters object based upon the name that we specified here. No matter what we type in, we'll see this in a minute when we test it. We're going to do /procedures2 / and we just type the value 0, 1, and it's going to map it automatically into this variable. Now, because we said that it was not required, that's what the little question mark at the end tells Express. It might we might not get a value here, in which case the this partner role will be will be null. So what we want to do is we want to test for that scenario. So this is a good way to test for. I'm actually doing two different tests, because in JavaScript there can be different things. The variable could be initialized, but it could have a null value, or it could be completely undefined. So really, if you want to be complete, it's good to test for both. So we're saying if the variable has a type of, so we're not actually testing for the value that's in the variable. So the value isn't undefined. It's that the variable itself is undefined. So that's what we're saying here. If the type of that variable is undefined, and we do the 3 = sign, in JavaScript, the 3 = sign means that you want to do a more strict test, that not only does the value have to match, but the type has to match as well. So try to be as correct as possible here, and use the best syntax. So that's what we're saying here. If type of partner role is equal to undefined, or, that's what the double pipes means, or partner role is equal to null. Now we're testing for the actual value. So if the variable is defined, but it has a value of null, then what we want to do is we want to pass in just the empty input parameters to our stored procedure. And what we're calling here is we're going to call this get BP addresses by role. Let's maybe look at that one real quick. Get BP addresses by role. And what we can see here is if our input parameter isn't passed in, well, we had a default value at the stored procedure level, so it's going to default back to the value of 1. So we'll be okay there. That's why we can just pass in an empty value. Otherwise, we'll fill the input parameters, and this is the way we pass a single structure here to the input parameters. What we have to do is they have to be in a JSON format with the named parameter name, IM partner role. That comes from the name of the stored procedure. And remember, even if you see lowercase here, that's going to be converted to uppercase at runtime. If it's not in quotes, it will be converted to all uppercase. So keep that in mind. And then we give it the value from our input parameter partner role if we had a value coming in. Now the rest of this is pretty much the same. We load the procedure the same way. The main difference here is we're passing in an input parameter that could either be an empty array here, or it has been filled with the actual value. But as far as getting the results back and stringifying them and putting them in the output, that all looks the same. So let's go ahead and run this procedure as well. First of all, let's come over here. Let's change this to procedures 2, and let's add the value 2 to the end. So now it's showing us all the addresses for business partners that have a partner role of 2. And if I change this to 1, then we would see the data that has partner role of 1. Or if we want to test that our logic works looking for null, we can just take it off completely. And now we see it still runs. It didn't throw an error, but it defaults back to the default of the input parameter of the stored procedure. And I think even if I take this off completely, yeah, it still works because we're checking for null. If I put an invalid value in here, 4, well, then I get no data. This would be interesting. What if I put in some character data? Then I get nothing as well. Okay. So that gives you some idea of how to call a stored procedure with an input parameter. The last thing that I want to talk about is parallelization. Now we talked about how Node.js is automatically asynchronous, non-blocking, through the use of callbacks. We're able to move on to other parts of the logic. But we've also seen how a lot of times when we're dealing with the database, we have callbacks anyway, and we have to nest the logic into callbacks, and it can be difficult to orchestrate the parallelization. Although we get parallel execution of the code, we also, for instance, when we write back into the response object, we can only do that once. And we can only do that at the end of our processing after say for instance we want to call two stored procedures, they can't both write into the response object in their own callback. That wouldn't work. The first response would go back to the browser, and then it wouldn't be waiting for the second response. So even in this asynchronous nature, we need some way to have a sync point to know when all the asynchronous operations are done, so that, like in this case, we can have one consistent response to the client side that has the output from all the database queries that we do. And in this case, what we want to do is we want to call two stored procedures. In fact, the two that we just saw an example of here, but we want to call them both in parallel from one HTTP request and get the response to have the output of both the stored procedures. So let's see how we can do this. Of course, there's ways that we could do it kind of manually inside of each callback, set flags and stuff like that. But as it turns out, we'll go back to the async library that we used earlier. If you remember, in the previous exercise, we used async waterfall to help orchestrate the callbacks so that they weren't nested inside of one another. One of the other features of the async library is that we can do more efficient parallel, not efficient from execution standpoint, but efficient from a coding standpoint, particularly when we want to do two things in parallel, but then we want to have one final output. So that's exactly what we're doing here. Is we're just going to create two separate functions inside the async parallel call, one of which we'll call the PO header data. And notice, instead of taking the results and putting them in the response object, it simply writes them into a variable. So inside this callback, we're going to write into the variable, and then we're going to call the second procedure, and it's going to write into the same variable. And in some other programming languages, when you start doing parallelization, you use multiple threads. And of course, you have problems if two threads try to write into the same variable. You get locking and on the memory areas themselves. JavaScript doesn't have, or I should say Node.js doesn't have this problem, because technically, even when we do parallelization, we're not creating multiple threads. We're doing it within a single thread that is just a giant event loop. So we have no problem inside these two parallel operations writing into the same variable. It isn't as though we have to lock it or worry about thread contention or anything like that. That's part of the beauty of the Node.js approach to parallelization, is we remove a lot of the complexities that normally comes in a multi-threaded environment. And then what we see here is the async parallel. You could list as many functions as you want here, and then you have one final sort of catch at the end, and this block of code will only be executed by the async parallel once all the functions have returned back. And it can know this because you see here at the very end of each function, it calls this callback. And that notifies async parallel that it's done. And the async parallel is basically creating an array of all the parallel functions that have been executed, and it's sitting there, kind of goes to sleep and waits until it gets a response back from all the outstanding called functions. That way we can have a consistent response to the client side that contains the results that has the values that were populated from both of the inner functions. So if we go ahead and save this and we execute it, we will see procedures parallel. We see a single JSON object coming back to the client side that has the output results of both of our stored procedures that executed in parallel to one another. Now, up to this point, you kind of had to take my word for it that things are executing in parallel or things are executing asynchronously. Don't worry, we do have an exercise a little bit later, once we learn some more of the basics, where we'll explore this, where we'll really kind of see the parallel execution. We'll use WebSockets to respond in real time to the client side in the web browser at the end of each operation and allow you to see that parallel activity happening. But for now, just I guess you could just kind of trust me on this, but we can see the power that we have here. We have 2 stored procedures. You can have many stored procedures. You can have many different database queries that aren't dependent upon each other. We can trigger them in parallel and avoid the bottleneck that we traditionally have in a synchronous execution flow, and basically get more activity to the databases. As we learned early on, the more we can take advantage of the parallelization capabilities of the database to do massive amounts of queries simultaneously, the more we can take advantage of the power of HANA itself.